Hello, my name's Mark and I'm G-Code Tutor. So in this video, we're going to look at how we can reduce our cycle times from a pre-written program. So let's go ahead and make a start. So this is the program that we're going to go over and edit to speed up. And you can see on the top above me here that we are making a screw bush with a ball going through the middle of it. Okay, so let's start by having a look how we can speed up this program. So the header doesn't contain any information that's going to help us speed up, but right here in the roughen cycle, I've found my first air move. So let's take a look at that. So when I program my parts, I always approach on two separate lines. That's one rapid to just off the face of the part, and then one extra move that takes it a little bit closer. So once the machine is running, we can remove that to speed things up a little bit. I only do that mainly for the setup, make sure if there's any mistakes there, I can correct it before there's a crash. So let's take a look at this line. Here we're rapiding in to the just above bar stock size, the X35 there, and we're coming in at 5mm off the face of the part, and the cooling goes on. And then after that, we're using a GO1 move to move closer to that front face and Z. But we can undo that, we can remove that GO1 line, it's not needed, and we can rapid closer on that Z above. So if we edit, it's going to look like this, and then that final line there, that GO1 X minus 0.2, that's facing the front part off. So now we're rapiding straight to 50 microns away from that face. So that saved us a little bit of movement time there, especially because we're using the GO1. Okay, let's move on to the next one. Now, on the finishing cycle, we've got pretty much the same thing here. So we can do exactly the same thing here. And this is coming into face off as well. But this time we're facing off at Z0 because we're not leaving on anything as we did in our roughing op. So we can change this line to this, our G00X35Z5 there, and then a GO1 after, where we can move that GO1, we can remove that line and replace the Z in the line above it to Z0 like this. And then after that, we're then going to face down and then finally rapid away back up to bar size and 2mm away from the front of the face. So that's added a few more seconds there to our finishing cycle as well. So now we've probably saved maybe 4 seconds altogether just doing those two lines. So the next line we can look at to speed things up is on our grooving cycle. So I'm using a G75 cycle here to groove our slot. Now there's not a great deal we can do with that. I already made it quite efficient when I was programming it. But this line above, again, we've got another air move there. We've got another rapid move that's coming in on two different lines. Now it's both rapid moves, so we're not saving that much time here, but we can still save maybe half a second or so. So that G00X35Z5, and then that's on one line, and then we move it to Z-30 to the position of that groove on the second line. Well, we can do that in one move. We don't need to rapid to the front face and then rapid, then move again back to that slot. So again, the reason I do this is for safety during setup, but once the machine's going, once the program is proven, once I'm confident it's going to run fine, we can then make these small adjustments. Now if we carry on down on our groove tool, we can see here we've got a G00X35. So what that's doing is once we've done our groove, it's going to wrap it up to our stock bar diameter, plus a little bit to give us some clearance. But we've already machined all this. Our major diameter now of our bush here is now down to 25mm with the stock bar behind it. That's going to be 33, 34mm, whatever our stock bar size is. So we can take that X35 and we can make this X26. So straight away, we've saved a bit of room there, a bit of movement, and we don't need to rapid right back up to bar size because we only need to rapid out the way of our part. So we've cut off some distance there as an extra 9mm we've removed. But again, it's a rapid move. So we're not saving that much time really, but every few seconds count here. Okay, so that's the first section of the program. The second section of the program, this covers screw cutting, center drilling, boring, and finally parting off. So let's have a look how we can speed up our program here. So we're going to start off by looking at our screw thread. There we've got our rapid move to X18mm, Z5. So we're coming into the front of the part, we're coming in at depth for the thread on the first cut, at least on the OD there, and we're coming in at 5mm away from the front face. Now, we could reduce that Z 5mm there, so the screw thread starts a little bit closer to the part, but we're not going to. Now, the reason for that is quite often with screw threads, we need a little bit of a run up to get rid of any backlash, etc., to make sure that thread produces good and also gives us a good surface finish. If there's any backlash in our slides there, it's not going to give a very good surface finish. So with screw threads, it's good to give a small run up of 5mm or so. And although CNC machines use reoccurring ball lead screws, it doesn't eliminate 100% of the backlash. There's still maybe a little bit of play there. So this just makes sure there's no play in the backlash as we're approaching. Now, this is an old skill that's followed me from manual turning, but I have seen cases where I've started a screw thread at 1mm, say for example, and found the finish and the dimensional accuracy was a lot worse than giving it a little bit of a run up. Okay, so that's our screw thread we're not going to change. So next up, we got our center drill. Again, another air move here. We've got a rapid move to X0, which is the center line of the part, 5mm away. Then the next line, we rapid in those 4mm, so it's only 1mm away. Now, once that's fine, once we know the center drill's fine, it hasn't crashed yet, we haven't broke that tip of the center drill and it's smashed the screen right in front of our face. Tell me how I know that happens. So we've got that, so we can now reduce that line so it looks like this. So now it's G00, X0, Z 1mm before we put the coolant on. So that's saved a few millimeters of rapids there as well. Now as we go down to our G82 cycle, because we're using a counterbore cycle here, now we don't really need a G82 here. G82 cycles allows us to add a dwell to a drilling cycle, and that P1000 there is that dwell. But we don't need that because it's not a finished item. We're going to center drill it and then we're going to drill it. So we can change this to point, and it may speed things up quite a bit. So how we can change this is by getting rid of that P1000 there, so we don't have a delay there. That saved us a second straight away. And then we can change this to G01. So we've got a G01 move now, Z minus 3.5 and a feed rate. And then once that's done, it's going to wrap it out. So cycles are not always best. In something like this, it's just as easy and slightly quicker to single point program that center drill there. So as we come down now, we're now getting to our 9.5mm drill. That's our pre-drill for our 10mm bore that we're going to do with a boring bar in a minute. So after we've set our G97 here, we've got another rapid move, G00, X0, Z5, and then on a separate line, we're coming into Z1. And at the end, once we've hit that G80, we have another rapid move there. It's 5mm away from the part. So what can we do to speed up our program with these lines? Well, we can get rid of that second rapid move straight away and rapid straight to 1mm off the front face of the part. And that second line there, we don't need to rapid out to 5mm. As long as we're clear, we're clear. So I'm going to change that to rapid to 1mm outside the part before we send the tool home for a tool change. Still gives us plenty of clearance and still safe. So we've got rid of some more air moves there as well. Now the next one is under our 6mm boring bar. And now as we come down on the here, we can see G00, X11, Z.3 before we put the coolant on. And then G01, G41, X10, Z minus 0.2, etc. So that's wrapped it into our boring bar and it's the start of the chamfer. So we can't really do a lot with that because that air move is critical. What we're doing is we're coming in to do a 45-degree deburr on the front face of that bore there. So we don't really want to play around with any of this because that's going to cause all sorts of issues with the wrong angle, etc. So that air move there is critical. We're coming in and it gives us that angle that we need. But as we come down a bit, we can see here we're rapiding out to G0, Z5. Now I normally put G00 here, but you can tell I've gone back to my old ways when I'm not teaching and using G0. So that's fine, they both do the same thing. So G0, Z5, we can change that to Z5 maybe to reduce that, that movement there a little bit. But again, not critical because we're using rapid, we're only saving milliseconds here really. So it's not a critical thing to change these when we're changing rapid distances. It's mainly if we can change any GO1s to rapids, that's when we really start saving the time. Okay, now finally we've got our passing off sequence. Now here we're rapiding into X35, which is the stock bar diameter plus a bit, Z minus 40, which is the length of the part, and we turn coolant on. Then GO1 feed rate commands, and we're feeding down to X minus 0.2. So we tend to go just past the center line to remove any pips, but we are passing off into a bore this time. So we can part off to that bore diameter instead of going down to the center point of the part. And then finally we wrap it away there back to X35 millimeters, which is the stock bar size again. So let's see how we can change that. Well, we could wrap it in lower. We could wrap it in just above that 25 millimeter diameter there. But it's not going to really save us much time. Again, it's all rapid moves, but where we have that feed rate, that GO1, and we're coming down to the center, if we started at X26, for example, that would be 9 millimeters less movement there straight away in a feed. So that would save us a lot of time. And we also don't necessarily need to come down to the center of the part. We've got a 10 mil ball there. We could come down to say 9 millimeters. So this way we've just saved 18 millimeters of travel just by changing these few lines on the parting off tool. But we do need to be careful because right next to the parting off tool, we have that major diameter there. And if we're wrapping it in below 35 millimeters, the tool is going to be smaller than our stock bar size. So I would still start at X35, but I would not come right down to the center of the part. That's how I would speed up this section personally. But I've seen plenty of people rapid to X26 mil instead of X35. Okay, so that's a very quick look over of how we can reduce the cycle times on this simple screw bush. Now, if you want to know more about G-code programming, computer-aided design, machine shop maths, measuring equipment, computer-aided design, as I just said, all of that stuff, I've got courses and free articles for everything over on my website that really help you increase your knowledge on machining and get you up to speed on maybe the latest programming techniques with G-code.